This is slide, it's a Qualcomm perspective. That's what I said. We submitted this a few weeks ago, and this is in the context of 6G. There's a study which is referred to as FS6G MAT. It's about basically preparing some media-related topics on 6G. And one of the topics which we got identified is that there's a belief that AI traffic will be something that will be relevant in the 6G area. So there's different. I have also internal discussion with some people say this will dominate everything. Others say, man, it's just traffic like 10%. There's still be a lot of video and so on. So, but anyways, it's new traffic. It's something that hits networks which was not there before, and there's little understanding how this traffic is. I mean, we have a good understanding how video traffic looks like for adaptive streaming, for maybe conversational calls, and so on and so on. And it's not only that SA4 has started an idea here. Actually, it's slightly different. It's much more that the rest of 3GP has done a lot of starting points on this and is kind of looking now at SA4 and asks, how does this traffic look like? Do you have input for us? And they have different questions. The questions are more like architectural traffic type related, but they're also from the characteristics from like, is it bursty and so on and so on? Is it and so on? They have a couple of more questions that are not yet here, but I need to extract them. So what I just say is the train on 6G and air traffic has left the station. It's unstoppable. And once in a while, if it's unstoppable, it runs very fast in 3GP. So now, before going further, you can approach this idea that you understand this by different means. You can do research paper analysis. You can maybe rely on third-party sources, review analytic environments. You just trust people, right? What they say. Now, me personally, I am very much like I want to see to believe, right? So maybe that's also because you might know that Thomas was the one guy in the Bible who didn't believe, so he wanted to see this. So maybe that just comes from that. But we have basically also said in Qualcomm that we would like to get a better understanding what we're talking about and analyze AI traffic. So now I go now into the details. The main scope of this 6G AI traffic characterization is to measure traffic of generative AI services predominantly right now, LLMs, image video generation, but it's not exclusive to this. So this is just the first starting point. Another is also agentic. So agentic traffic is something which we believe will be different. Why is it different? Because a user can consume a certain amount of information at some point in time. So you look at a web page, you read it, then you move on, or you watch a video, but you don't do like 100 things in parallel. Agents operate differently. I give you a task and ask, give me the cheapest flight to Berlin for MWS, right? So it will search all websites at the same time. So there's a lot of bursty traffic, and agents will optimize this further. So it's unclear. There's certain aspects that we believe could be different. So the nature. There's another aspect. So you need to understand if you have good or bad network conditions, that this results in a quality of experience. So how do you perceive it, right? Is it working well or is it not working well? So now you need to understand what is the metric for this type of thing. So that's a bit of a definition. We understand it for streaming. Maybe we say if you see a variable bit rate, stuttering, low quality, that is impacting you, or wrong startup. What is the quick QE here? And so we started 3GPP on this one, and there is basically a TR, or it's part of a TR of the in the AI traffic characterization. So we have a technical report, it's 26870. I did not put it here. And in the annex, we documented now already for the 6G study this AI traffic characterization testbed, and there's a second part, which is the emulator. Now, beyond this scope, this is an open source testbed for not only AI, but general media traffic evaluation, we believe. And we don't want to say this is the ultimate truth. We just want to give a starting point that people can develop along with this, improve, and maybe even understand the limitations we're having. So it's not that this is necessarily ultimately the truth, right? It is one approach, and we hope that we get more community to support this. So it targets 5G 60 and realistic UE observed network condition. It supports 3GPP-4 studies and broader media delivery evaluation and can be extended and may be used for other purposes. And I get there in a second. So there is beyond air traffic extended use cases. So we have in 3GPP-4, and I pulled this together quickly just for now. So apologies, not everything is here. Generally, the evaluation of media delivery protocols, HTTP, Quick Web RTC, and we have 3 studies that are ongoing that might benefit from this as well. This is not something we impose. We believe there's an opportunity to leverage commonalities here, pointing to this quick-based streaming. So there's a study description here, and this aims to evaluate the performance of quick-based streaming technology against additional TCP-based approaches for various media services in 5G and future networks. Study builds upon explorations that we already did in the AMD. But you find it here, and here the idea is also to have a platform for actual evaluation. And this is a bit targeted towards quick, or saying what are quick-based protocols? Is there a benefit or not? And an equivalent exists for real-time communication for quick, which is on the Q4 RTC mat. There is a general assumption that those build on a common emulator, and we hope that we can basically use the same network emulator for all of the studies. There's a third one, which is looks into dynamically changing traffic characteristics, which is an SA2 QoS concept that is that was predominantly developed for XR, this PU set concept. But the question is whether this can be carried forward for other purposes as well. And I would believe, as I said, general media and application testing under 3GP network profiles. And 3GP is actually maybe not even correct because these emulators are generic enough, so it doesn't have to be 3GP centric. Okay, so that's just as a side discussion. So this is the core platform. And there is 2 pieces. So this is the whole 6G AI testbed, right? But then you have a piece here that is independent. So you have this middle part is the emulator, right? And it's more or less a logger of the traffic. So the network emulator is basically building that you can put traffic on networks and do a certain amount of evaluation. I get there in more details. And then you have around this the ability to have scenario orchestration. And this scenario orchestration basically builds a scenario of what you execute in terms of testing, right? So, for example, what you said, coding with prompting and so on and so on, or agent-based, or just voice perception-based aspects, multimodal analysis, and so on. So there are a couple of those, and I get there as well later. There's a couple of aspects that makes it AI specific. So you have an LLM client layer, right? And that connects to the internet LLM APIs and tools that you need to convert. And they were explicitly exposed here. So we have been working with OpenAI, Gemini, Mistral, DeepSeek, and so on and so on. There's already a warning here which should be put. Okay, so this is something where if you run tests, you need to get to get token access. So this is not something which is automatically available because this is there. So there's also questions about reproducibility and so on, which are good questions. And I cannot all answer. There's an attempt to basically have a certain amount of reproducibility. There's also obviously that some of these aspects, like latencies, depend obviously not only on the network condition, it also depends on the compute power on where the LLMs are applied. And there's also ideas that you can do this in a closed environment, right? So where you basically run the LLM server in your own premise, or you put it into the cloud. So different aspects. All of this is there. These are all discussions that basically need to have. But again, so we separated into two pieces: the network emulator and the 6G AI testbed. NetEmu. So you can go to this and follow this. And what it does, it's a lightweight Python wrapper around the Linux traffic control TC-NetEm used to emulate realistic network profiles. And what are the features? So it emulates delay, jitter, packet loss, and bandwidth limitations, rate limits. It supports bidirectional shaping via IFB devices, includes 27 plus defined profiles aligned with 3GP concepts like 5QI mappings. There's a contact manager designed for automatic setup and cleanup and can be used independently of the AI testbed. Okay. Now we can look into the repo and do this together. Let me just check.
Can I ask what an IFB device is?
No, because I don't know either. You need to look it online. I just copied off.
I think it's internal frame buffer.
Okay, yeah, you're right.
Okay.
Sorry.
It's basically a network loopback device inside the Linux kernel.
Okay.
Yeah. So maybe I go a bit to this and then we look a bit into the repo, what is in there, right? So I extracted a few things. Okay, but that's basically it here. And on the network profiles, these are just examples. What we did is the repo includes predefined network profiles representing real world and future scenarios, such as an ideal, let's say 6G. So zero latency, no loss. So basically the network is not even existent. Then you might call it a bit 5G urban. I don't know whether these exist. Good Wi-Fi, edge coverage, satellite, NTN. So, I mean, we want to be careful, right? But we could also, a benefit of 5G MAC could be to define profiles that are representative, right? So, and the profiles are defined here. As you see, these are just a bunch of JSON and YAML examples, which describe the delay that is applied, the jitter, the loss percentage, so independent packet losses, and the rate limitation. And these profiles should allow repeatable experimentation across vastly different network conditions. So now you could say, I want to understand how a certain test scenario performs over a satellite link, which have typically delays of 600 milliseconds. Another aspect which we attempted to address, which I like, but some others have an issue with that, is 3GP defines 5 QIs in the 5G context. Likely there will be a 6 QIs as well, six QIs. But they basically give you a promise of what the network provides you. Bitrate guarantees as well as loss guarantees and so on and so on. So you could now test applications under the assumption that you have asked the network for a 5 QI. So is it worth for my application to run under quality of service, or do I just operate on a best effort? So what would be the difference? I mean, this is an interesting topic because that's where the operator benefits comes into play, to invest in network and basically do traffic treatment in a way that you get improvements, right? So this is more, you say, I emulate the network from an idea. The other one is I abstract myself from a network, but I go into a QS profile. So that is supported as well. Okay, I stop here for a second. And so this is just a selected set of profiles. There are more which are already defined, but it shouldn't be hard to define more. And I'm pretty sure that NetM might allow more aspects than defining these parameters, but I don't know these details, so we need to check it shortly. So this is now the AI test bed, and I just summarized it here. The key capabilities. So we have 11 plus AI test scenarios, and I think we have a document which I didn't have time to integrate yet. But the test scenarios right now, they were not necessarily developed taking into account the SA1 use cases, but we did an inverse mapping to SA1 existing use cases related to AI. this includes, for example, a bit more chat-based LLM interaction, right? Textual, adding images, and so on. Agentic AI using the MCP tools, image generation, multimodal text, audio, image, video understanding, perception, and real-time AI. So something where you have your voice call and maybe you do a translation, or you speak with your perception glasses into the network and want to understand. So this is real-time AI via WebSocket, WebRTC. We have APIs to 8+ LLM providers, including OpenAI, Gemini, DeepSeek, Virtual LLM. This is locally hosted and real-time variants. Then there is a definition of 60 metrics, and we need to learn with this metrics. So, for example, now some might argue there is a token is maybe already a specific aspect that you use, but very often, obviously, you use tokens. So, meaning the first traffic, the blob of a JSON prompt, and the responses are handled here. And if you have this, how long does it take to get to the first and last token? Latency percentiles, uplink, downlink traffic ratios, and I have a bit more of these results showing already later. Token throughput rates, agent loop factors, that's all included. There's many more metrics, and we need to learn, can we measure these metrics? Are they useful? Are they generic? And so on and so on. What do they mean? There's traffic capturing on different levels, on a TCP dump level and an L7 with the MIT TM proxy. And then there's a structured logging using an SQLite for post-analysis and reproducibility. Again, that's where obviously we need to work on this. So you get a lot of data, so can we combine it? Can we extract information and so on and so on? So that's available here. I stop. Well, let me just move forward. These are a couple of the metrics that I already mentioned. They are defined here, and uplink ratios, downlink ratios, and so on and so on. These are test scenarios in a bit more. So they have a basic chat. You have a chat streaming where you stream tokens, continuously small chunks. Chat conversational, shopping agents, web search agent, general agent, image video generation, direct web search. So, okay, what does it test, right? I mean, the first one tests just a single turn text. The second one does token streaming. Then you could do real-time audio via WebRTC. Shopping agent, you test MCP tools, search and fetch. Web search agents, so that's kind of a research workflow, and general agents, so it tests a full set of MCP, image generation prompts plus binary input. You might say make it similar to this image and so on. And direct web search, parallel HTTP, no TCP, MCP. So that's, for example, what we heard from some of our colleagues who observed some of these things. They just say if you run a local agent, for example, that one is grabbing a lot of data from all web pages at the same time, right? And that aspect is calling a lot of parallel HTTP requests. Whatever it means for you, that might be very confusing. You never saw this net traffic before, right? But if you run an agent locally, these type of things can happen. And then you see a bit what you could expect in pattern, but that needs to be validated. Up rate, downlink ratios, smaller chunks, real-time audio running on the network, multi-burst, multi-hop requests, variable latency, multi-stage. I mean, that's what we also know, that within running such an application, you might have different traffic flows that have different latency requirements, and also different protocols. There could be a variability of things happening at the same time. And you would not say all of this is completely new from what you would see in a behavior of humans doing certain things, because maybe you do it as well as I do, parallel things once in a while, but it might be coming up more systematic. Okay, so that's just one here. Let me just finalize. This is kind of an overview. Different scenarios have been tested. There was a question on the latency. The second one, time to first token heat map, right? So how long did it take to get access to the first token? I think that's more obvious. And then there's a last one, which maybe is the most obvious, is just checking what is the downlink uplink ratio that you do, right? And if you have for example, a small, then the uplink ratio is much higher than the downlink ratio. So you might see very asymmetric things, but your image generation, you have obviously a high downlink because you're uploading, just give me an image like this, and then the downlink gives you this one. So this is also being observed here. So some of them have symmetric traffic running, some of them have a very different behaviors. This is what I have on slides right now. Again, I'm happy to dive a bit more into the repos, answer other questions, and so on and so on. But let me stop here now. Thank you.